स्टूडेंट्स, अभी तक हमने एबायोटिक फैक्टर्स में से टेम्परेचर एज एन एबायोटिक फैक्टर एंड लाइट एज एन एबायोटिक फैक्टर स्टडी किया। अब हम बात करते हैं लिथोस्फीयर और सॉइल की। अर्थ इज अ cooled spherical solid planet of solar system which rotates on its axis and revolve around the sun at a certain constant distance. The solid component of earth is called lithosphere. The lithosphere is multi-layered, including three main layers: crust, mantle and core, which is divided into outer and inner core. The core is the central fluid of vaporized sphere having diameter of about 2500 kilometers from the center and is possibly composed of nickel iron. The mantle extends about 2900 kilometers above the core. This is in molten state. The outermost solid zone of the earth is called crust, which is about 8 to 40 kilometers above the mantle. The crust is very complex and its surface is covered with soil, supporting rich and varied biological communities for living organisms found in the soil, an environment providing food, shelter and concealment from predators. Now let us talk about the soil. The word soil is derived from a Latin word solum, meaning earthy material in which plants grow. The science which deals with the edaphology, edaphos means soil. The study of soil is significant for us due to various reasons. Soil is a natural habitat for microorganisms, plants and animals. Its knowledge is helpful in practices of agriculture, horticulture, forestry, etc., such as cultivation, irrigation, artificial drainage and use of fertilizers. Now let us talk about how the soil is formed. Soil is a stratified mixture of inorganic and organic materials, both of which are decomposition products. The mineral constituents of soil are derived from some parent material, the soil forming rocks, by fragmentation or weathering, while organic components of soil are formed either by the decomposition of the dead remains of plants or animals or through metabolic activities of living organisms present in the soil. Process of soil formation is completed in two steps. First is the weathering or breakdown of bigger rocks into fine smaller mineral particles. Soil formation is started by disintegration or weathering of parent rocks by some physical, chemical and or biological agents, because of which the soil forming rocks are broken down in small particles called the regoliths. Regoliths are the basic materials which, under the influence of various other pedogenic processes, finally develop into mature soil. Soil is formed by the three types of processes. The physical weathering agents are primarily climatic in character, exerting a mechanical effect on the substratum with the result that fragments are comminuted into progressively decreasing particle size. Such climatic weathering of rocks does not cause any chemical transformation of rock minerals and commonly occurs in deserts, in high altitudes and in high latitudes. The agents which are involved in climatic weathering of rocks are temperature, water, ice, gravity and wind. There is chemical weathering also. The physical disintegration produces a greater surface area of rocks exposed to the chemical weathering, which occurs simultaneously with physical weathering and continues much beyond that. During chemical weathering, a chemical transformation or decomposition of parental mineral materials into new mineral complexes or secondary products occurs. For example, primary minerals that contain aluminium and silicon, such as feldspar, are converted to secondary minerals such as clay. Because chemical weathering requires the presence of moisture and air as essential factor, therefore chemical weathering is not affected in the deserts. Then the weathering occurs by the biological processes. These are called the biological weathering. Though the surface of the bare rock is unsuitable for many forms of life, even then a number of microorganisms like bacteria, protozoans, fungi, nematodes, etc. and lichens and mosses can gain a foothold. These early colonizers transform the rock into a dynamic system, storing energy and synthesizing organic material. Their activities alter the mineral composition as well as the physical structure of the rock. For example, lichens are present in the initial stages of biological succession and their growth may cause cracking or flaking, exposing greater area of rock to further weathering. The lichens and mosses extract these elements are combined with organic complexes and eventually return to the developing soil when the vegetation decomposes. Mineralization and humification occurs. The decomposition or withering of inorganic soil matter is followed by decomposition of organic matter, which is started at an early stage of pedogenesis and continues up to the much later stages. Now let us talk about the soil profile. As you can see, the soil is divided into many zones which we can discuss one by one. Soil profile is the term used for the vertical section of earth crust, generally up to the depth of 6 feet or up to the parent material, to show different layers of horizons of soil for the study of soil in its undisturbed state. It is made up of a succession of horizontal layers or horizons, each of which varies in thickness, color, texture, structure, consistency, porosity, acidity, and as well as in the composition. In general, soils have 4 horizons: an organic or the O horizon and 3 mineral, that is A, B and C horizons. Some workers recognize a D horizon in which rocks are in active weathering state in between C and R horizons. R horizon is a consolidated bedrock on which a soil profile rests. A and B horizons form the true soil or solum. Each horizon of the soil profile is further subdivided. Horizon subdivisions are indicated by the Arabic numbers, that is O1, O2, A1, A2, etc. Different horizons of soil profile have different characteristics. Let us first of all discuss the O horizon. The O horizon is the surface layer forming above the mineral layers and composed of fresh or particularly decomposed organic material. As found in the temperate forest soils, it is usually absent in cultivated soil. O horizon contains both kinds of humus and is subjected to the greatest changes in soil temperatures and moisture conditions, and contains most organic carbon. O horizon and upper part of A horizon is the region where life is most abundant. A horizon is characterized by major organic matter accumulation, by the loss of clay, iron and aluminium, and by the development of organo-mineral complexes. Granular crumbs or the platy structures. Now let us discuss the B horizon. B horizon is the mineral horizon. It lies below A horizon and also called subsoil. It is characterized by an alluvial concentration of all or any of the silicates, clay, iron, aluminium and humus alone, or in combination, and by the development of blocky, prismatic or the columnar structure. Now the below the B horizon and above the surface of the withered parent rock is the zone of regolith or the sea horizon. It is a light colored horizon containing withered parent material, and then there is R horizon. Below all these horizons may lie the R horizon, which is the region of consolidated rock. Now there are different types of the soils. In the field, differences among soils and among horizons within a soil are primarily reflected by variation in the texture, arrangement and structure and color of the soil. The texture of a soil is determined by the production of different sized soil particles. Mineral fractions or particles of soil are called soil fractions or the soil separates. The soil particles have been classified into gravel, sand and clay on the basis of their size differences. Gravel consists of coarse particles larger than 2 mm. Sand ranges from 0.02 to 2 mm in diameter and easily seen and feels gritty. Slit consists of particles from 0.002 to 0.02 mm in diameter, which scarcely can be seen by the naked eye, feels and looks like floor. Clay particles range below 0.002 mm in diameter and are too fine to be seen even under the ordinary microscope and are colloidal in nature. Clay controls the most important properties of the soil, including plasticity and exchange of ions between soil particles and soil solution. Most soils are a mixture of these various particles. Based on the proportions of the various particles contained in them, soils can be grouped into 5 textural groups. First of all, the coarse textured soils are loose, consist mainly of sand and gravel. They retain very little moisture and supply some plant nutrients. Moderately coarse soils include sandy loam to very fine sandy loam. And medium textured soils are mixture of sand, slit and clay high enough to hold water and plant nutrients. Moderately fine textured soils are high in clay. They are moderately sticky and plastic when wet. They may form a crust on the surface if organic matter is low. They have a high moisture holding capacity. The fine textured soils contain more than 40% clay, may be sticky and plastic when wet and hold considerable water and plant nutrients, but may have restricted internal drainage. Then what is the effect of soil on the plants and animals? Soil is a habitat both for animals as well as for the plants. Soil is used by various animals as a refuge from enemies, to escape desiccation and extremes of temperature, as material for abodes, and as a Clay is cold, dense, poorly aerated, and though it holds much water, does not give up water readily to plants and animals. Sand is dry, loose, and has a variable temperature. Rock heats and cools quickly, has little available water, and practically no air. And is usually too resistant to allow penetration by burrowing animals. Alkaline soils are physiologically dry because the salts present hold the water so that it is not readily available to the organisms. Humus has a great water capacity and gives up water readily. Is usually well aerated and furnishes nitrogen as well as mineral salts and water. It remains rich in biota. Peaty soils are raw humus and are uninhabitable for most animals because they are poorly aerated and have an acid reaction. In general, the character of the vegetation cover serves as a good index of the habitability of soil for animals. Conditions that make plants flourish are usually favorable for animals. And this is the what we want to know about the soil. Soil affects both plants and animals. You have better known in this lecture. Thank you.